All right, so in arithmetic, we're always using constants. Now, first things first, what is a constant? A constant is a number like 28 or 5 or 2 or 4 or 7, just a number. It never changes, right? 5 is always 5. And when we're working with constants, it always makes it easy to evaluate our expressions. Now, what does it mean to evaluate an expression? Well, here's an expression right here, 28 plus 5. And to evaluate an expression means tell what number it's equal to. Well, that's not hard. 28 plus 5 is 33. Right? And just like in our second expression, we have the constants 2, 4, and 7. If we want to evaluate this expression, we want to say, what is this number sentence equal to? Well, it's equal to, let's see, 2 times 4 is 8. 8 plus 7 is 15. All right, life is groovy. Now in algebra, things get a little trickier when we begin to introduce variables into our expression. Now a variable is something like our classic letter x. Now it stands for a number, but we don't know what number it is. And in fact, what number it stands for varies. It can be anything in this case. So if we wanted to evaluate 2x plus 5, well, that'd be a lot harder because we don't know what x is equal to. I think it's important that we take a moment to tell what an expression is as well. An expression is just any number sentence that involves constants and or variables and any operators. So things like 5 and 2 and x or maybe y or maybe cloud or lightning bolt and operations like addition, subtraction, multiplication, division. That's an expression. Okay, next page. All right, now like we said before, we can't evaluate an algebraic expression like 2x plus 5 unless we know the value of x or any other variables that might be present. So for instance, we can't just say evaluate 2x plus 5. But we can say evaluate 2x plus 5 if x equals negative 7. And you say, okay, no problem. All I'm going to do is replace that x with a negative 7. And now we are able to evaluate this expression. We're able to say what number this is equal to. So let's see, 2 times negative 7 is negative 14. Negative 14 plus 5 is negative 9. So basically what you're saying is, hey, this expression, if x is equal to negative 7, this expression is equal to negative 9, right? And like we said before, x is a variable. It can equal any number we want. So you could say, evaluate this expression if x equals 14. No problem. 2 times 14 plus 5. All right, 2 times 14 is 28. 28 plus 5 is 33. Fantastic. Now we can have simpler expressions and we can have more complicated expressions with a number of variables. For instance, the expression 4 times x plus 3 times y plus x squared. If we want to evaluate that expression, we need to know the value of both x and y. So let's evaluate it. Let's say what it's equal to if x equals 2 and y equals negative 5. So we're going to substitute in a 2 for x. We're going to substitute in a negative 5 for y. And we're going to substitute in 2 for x. Again, of course, wherever we see an x, we're going to substitute in that number. So 4 times 2 is 8. 3 times negative 5 is negative 15. 2 squared is 4. I think we end up with a grand total of negative 3. So negative 3 is the value of this expression if x equals 2 and y equals negative 5. All right, not so bad. Next slide. This unit is going to be all about equations with unknowns. Now, what's an equation and what's an unknown? An equation is what happens anytime you have one expression and another expression and they are set equal to one another. That's what an equation is. That's it, right? For instance, down in the lower right, here's an expression. Here's an expression. They're set equal to each other. Now we have an equation. A lot of people use the word equation a little too loosely, so let's make sure when we talk about equations, we're actually talking about an equation. What's an unknown? We'll look at our first example. X minus 7 equals negative 3. Now, x we normally think of as a variable. It could take on any value. In the context of this particular equation right here, there's actually only one number that's going to make that statement true. So x isn't really a variable anymore. It kind of has to equal just one value. So I kind of like us to call x, in this case, an unknown. Maybe an unknown variable, but it's really important to know that x can't just equal anything in this case. There's only one value in this particular equation that's going to make it true. Perhaps you know what that value is. That value is, do you know what it is? 4, right? If x were equal to 4, then that statement right there would be true. And that leads us to our next definition, which is a solution to an equation. A solution to an equation is any number or numbers that when you substitute it in for your variable or variables, it makes the equation true. That's it. We're just looking for numbers that make all of these equations true. So let's go through them. Let's see if we can find those special numbers. In our first example, x plus 9 equals 18. Can you figure out what number makes that true? Yeah, I think that number is 9, right? If x were equal to 9, that would be a true statement. So we'd say 9 is the solution to this equation. Ooh, this one's a little bit tougher. Can you find the number that makes that equation true? We're going to learn a lot of techniques for solving more and more difficult equations, but you can always fall back on your intuition. In this case, right, you say, well, listen, if this minus 8 equals 10, then I think negative 3x kind of has to equal 18. If negative 3 times some number equals 18, I think that number x actually has to equal negative 6. And you can test to make sure you've done everything correctly by actually substituting this number in for your variable and seeing if it makes the statement true, right? Negative 3 times negative 6 is 18. 18 minus 8 is 10. Fantastic, amazing. We're going to see all sorts of different equations, including this one on the lower left. Maybe a little tough, right? 4/7 of what number is going to be equal to 12? In this case, our solution is 21. Now, in this case, I'm just telling you all the solutions. We're going to learn all the skills to actually find them on our own, but I'm also showing you that you can just use your intuition as well. Last one. This one's a lot tougher. We're going to learn how to do this one on the lower right as well, but one question that I like us to be able to answer is, hey, is 4 a solution to this equation? Like, I don't know. I don't know how to solve it. I can't tell you what the solution is, but we can test 4 and see if it actually works. And all you do is you substitute in 4 for your variable anywhere that exists and see if you get a true statement. Here's a key point. Whenever we're testing and we're not sure whether we have a true statement or not, I like to let the reader know that by putting a question mark. We're saying, hey, I don't know, reader. Are these equal? We'll find out soon. 3 times 4 is 12. 12 minus 2. Is that equal to 20 minus 8? Let's see, 12 minus 2 is 10. Is that equal to 12? No, 10 is not equal to 12. We can go ahead and definitively say that. So since 10 is not equal to 12, the number 4 does not make this equation true. The number 4 is not a solution. We could use a guess and check. And if we find a number that did make this equation true, hey, we've found our solution. But the skills for solving tougher solutions like that, that's what's coming up soon.